create something exceptional, your mindset must be relentlessly focused on the smallest detail. That's one wonderful quote by an Italian fashion designer, Giorgio Armani. Indeed, true excellence emerges when one doesn't neglect even the tiniest elements but instead embraces them as essential components of a larger vision. In the context of our discussion today, this quote inspires us to recognize the significance of the finer aspects of the world. This quote also perfectly encapsulates the essence of drilling machines, grinding machines, and lathe machines in workshop practices which we are about to tackle today. These tools are the heroes of many industries, helping us to transform raw materials into valuable creations that we use every day. Good day everyone, we are Group 7 and we are about to discuss some of various machine operations with these tools, the drilling, grinding, and lathe machines. Starting off with the first machine, we have the drilling machine and the drilling operations. The drilling machine can also be called a drill press. This tool is frequently used to drill round holes in metal. In fact, the definition of drilling machines is significantly broader and it encompasses any models created specifically for the purpose of drilling holes in a metal. On a drill press, a variety of other tasks can be done. There are sanding, counterboring, countersinking, honing, and these are just a few of them. To drill a hole of the right size, considerable skill is needed at a high rate of production in the exact intended place. So basically, a drill press is a machine that is used for drilling holes in different materials. We already know that, so let's now talk about its parts. So here are the components of a drilling machine and their specific functions. We have first the head. Different machines have different drill press heads with different designs. The electric motor is typically fastened to the head of the machine, and the V-belt drive is used to move the spindle between 3 and 5 different speeds by stepping the V-belt on the pulleys. The head contains the motor, the pulleys, and the spindle. Next, speaking of spindle, we have the spindle. The spindle is the component that rotates in a drilling machine. Typically, it is splined and constructed of steel alloy. In a wheel or other device, the spindle revolves and moves up and down in sleeves that move on bearings. So a spindle is equipped with a chuck to hold and secure different sizes of drill bits. Next is the table. The drill press column serves as a support for the table. It may be swung around to be out of the way or shifted both vertically and horizontally to the optimum working posture. So a table must be flat and adjustable, of course, for proper operations in drilling machines. Next is the base. Basically, it is the bottom part and it serves as the drill press main structural support. It is large, casting with slots or holes or bolts to secure it to the bench for directly fastening the job or workpiece to the base. The origin supports the table and the head, which in turn supports the column. So it is usually bolted to the floor or workbench to prevent it from moving during operations. Next, the next part is the feed. On a drill press, the feed can either be manual or automatic. Feed is measured in thousandths of an inch for each spindle revolution. The feed of a twist drill refers to how far the drill travels into the job each spindle revolution. So this component is used to lower or raise the wheel and the attached drill bit. It provides control over the drilling depth in a drilling machine operation. Lastly, we have capacity. There are various methods to express a drill press capacity. Typically, the distance between the twist drill center and the machine's column is used to assess drill presses. Some drill presses are rated based on the distance between the tip of the spindle and the top of the table in their highest and lowest positions. So much for that. These are the parts of a drill press. Now let's move on to the types of drilling machines. So there are many types of drilling machine, but today we will be only discussing the three most common types of drilling machines. Starting off with the sensitive drill press. These machines come in bench or floor varieties. They are hand-fed, belt-driven drill presses. The operator of the sensitive drill press may feel the cutting action at the twist drill's end thanks to the hand feed. A hand lever or hand wheel is used to vertically move a counterbalance spindle. Small twist drills that are prone to breaking under power flow are used in these machines, which are made for comparatively light labor. Next, the second one, we have the variable speed upright drill press. A wider range of speeds is available when the back-geared drill press than with the floor-style sensitive drill press. It has a power feed and is bigger as well. The back-geared upright drill press reversing mechanism enables tapping operations as well. And lastly, we have the radial drill press. The vertical spindle in a radial drill press can be locked in a horizontal position and moved around by an arm that can be lifted and lowered on a vertical column. The spindle can therefore be positioned anywhere within its range. So these are the three most common types of drilling machines: sensitive drill press, variable speed upright drill press, and radial drill press. Let's now move on to the drilling machine operations.
Drilling machine operations. Each drill press operation requires careful thought, good judgment, and several trial and error. Challenging and rapid rules are not practical for drill press operation because a variety of factors, including material composition, hardness, machine type, condition, cutting tool condition, lubricant, hole depth, and many others, affect how quickly and efficiently a material can be worked. Before we discuss each and every drilling machine operation, let us watch this YouTube video.
Drilling. The drilling operation is shown in this video. Operation of producing a hole on the workpiece. Spindle, workpiece, drill tool, take a close-up look of spindle, drill tool, workpiece, tool rotation, feed direction. It is done to remove solid metal from the workpiece to produce a circular hole. Reaming. A typical reaming operation is shown in this video. Reamer, workpiece. It is the operation of sizing and finishing a hole already made by a drill using a tool called reamer. Tool rotation, feed direction. Smoothening the surface of drilled holes with the reamer. It removes only small amount of material of the order of 0.1 mm to 0.3 mm and produces a smooth finish and required size. Boring. The visual representation of boring operation in drilling machine is shown. Boring tool, workpiece, It is the operation of enlarging the already drilled holes to exact size. On a drilling machine, it is carried out by a boring tool. Counter boring. The counter boring operation in drilling machine is shown in this video. Counter boring tool. Workpiece. It is the operation of enlarging the end of a hole cylindrically as for the recess for a counter sunk rivet. It is to increase the size of a hole at one end only to a small depth. Counter sinking. A visual representation of a counter sinking operation on drilling machine is shown in this video. Counter boring tool. Workpiece. Pre-drilled hole. It is the operation of making a cone-shaped enlargement of the end of a hole as for the recess for a flat ahead screw. The tool enters the workpiece axially and enlarges the top portion of an existing hole to a cone-shaped opening. Tapping. The tapping operation is shown in this video. Workpiece. Tapping tool. It is the operation of cutting internal threads by using a tool called a tap. A tap is similar to a bolt with accurate threads cut on it. A tap is screwed into the hole by hand or by machine. Threaded hole. Spot facing. Spot facing is a mechanical drilling or milling process. After the initial hole is drilled, a larger well or recess is drilled into the material. The head of the screw or nail fits into this well. This allows the nail or screw to sit flush with the surface of the item that is drilled.
Now that we have watched the YouTube video, let us discuss each and every operation. The first one will be drilling. Drilling, or the process of removing solid metal to make a circular one, is the drill press main function. Prior to drilling a hole in metal, the hole is found by drawing two lines at an angle, and the center of the hole is then punched to create an indentation for the drill tip to let the drill start. The following are some of the examples of drill bits: spurwood bit, auger bit, flatwood or spade bit, HSS metal bit, SDS masonry bit, normal masonry, countersink and pilot hole, and quick release bit. The second operation will be tapping. Tapping, or cutting threads in a drilled hole, can be done with a drill press. On the drill press, precise hand tapping can be done with the work mounted on the table in the same manner as for drilling a hole. On the square shank of the hand tap is a tap wrench, and in the drill press hollow spindle is a lathe center. The tap is then inserted into the workpiece hole, and the tip of the lathe center is inserted into the top shank and center hole. Next operation will be countersinking. The countersinking procedure calls for securely securing the workpiece, placing the countersink in the drill shock, aligning the countersink with the work, choosing the appropriate spindle speed, and being cautious when feeding the countersink to the work. The next will be counterboring. Counterboring is the process of enlarging a hole cylindrically along a portion of its length. The diameter of the hole is increased with a counterboring tool to accept stud, bolt, or pin with two or more diameters, such as Philister head screw. The next one will be spot facing operation. The spot facing process is another process that is comparable to counterboring to provide a bearing surface for a washer, nut, or the head of a cap screw, just enough metal is removed. It is necessary to place the spot-facing tool in the drill press, spindle, and line the pilot of the tool with the previously drilled hole. The last but not the least will be reaming. Reaming is a process used to precisely size and finish a hole's interior. A drilled hole can be improved with reaming to make it more precise and smooth. A hole can be finished to precise dimension using a hand reamer. To produce an exact, smooth hole of a regular size, a hole should be bored 1/64 inch undersize and then machine reamed. The next will be setup and safety precautions in drill press operations. The following are the steps to be The next will be setup and safety precautions in drill press operations. One of the most often used instruments in metalworking and woodworking operations is the drill press. Workers can prevent any potential mishaps and injuries when using the drill press by adhering to these safety guidelines, which are 1. Conduct proper training. Without adequate instruction, your staff won't be able to use the drill press safely, let alone adhere to the safety regulations that apply to your workplace. By spending money on drill press training, you provide your operators the tools they need to spot risk and comprehend best practices. 2. Set drill press safety precautions, protocols, and procedures. It's crucial to take the time to study drill press safety measures and update your safety protocols. These are the best strategies for promoting general safety around your drill press equipment and your entire business. 3. Encourage proper maintenance. By promoting good maintenance, you may successfully increase the lifespan of your equipment while decreasing the need to buy new ones. This effort also lessens any downtime needed to fix damaged equipments. The last but not the least is use an OSHA compliant drill press guard. The OSHA, or the Occupational Safety and Health Administration, mandates the use of drill press guards that are consistent with their standards in order to ensure safe operations. This section now concludes our drilling machine operations. Now, we will move forward to grinding machine and grinding operations.
Grinding machines and grinding operations. Grinding machines are precision tools designed to remove material from a workplace by abrasion, typically using abrasive wheels as their cutting tool. They serve the primary purpose of achieving a fine and smooth surface finish, shaping or sharpening objects, and achieving precise dimensional accuracy in various industries, including manufacturing, automotive, aerospace, and construction. These machines comes in various forms, such as surface grinders, cylindrical grinders, and tool and cutter grinders, each tailored to specific applications. Grinding is a crucial for achieving tight tolerances, improving the functionality and aesthetics of products, and ensuring the quality and performance of a wide range of components and materials, making grinding machines essential in modern industrial processes. The next one is the parts or the main parts of the grinding machine. The first one is the column. The column's primary function is to maintain the alignment and position accuracy of these critical components during the grinding process. It ensures that the grinding wheel and workpiece remains in the correct relationship to each other, which is essential for achieving the precise and consistent results in grinding operations. The column is typically made of a sturdy material, such as a cast iron or steel, to withstand the forces and the vibrations generated during grinding and maintain the overall structural integrity of the machine. The next one is the work table. Work table in a grinding machine, also known as a workpiece table or workpiece support, plays a critical role in the grinding process. It is typically a flat and rigid surface on which the workpiece or the object being ground is securely clamped on held during the machining operation. The work table can be adjusted both horizontally and vertically to position the workpiece accurately relative to the grinding wheel. This adjustability allows for precise control over the depth and angle of which at which material is removed from the workpiece. The next one is the wheel head. The wheel head in the grinding machine is a critical component responsible for holding and rotating the grinding wheel. It's typically mounted on a spindle and plays a crucial role in the grinding process. The wheel head can be adjusted for height and angle, allowing for precise control over the depth and orientation of the grinding operation. By adjusting the wheel head, the operator can ensure that the grinding wheel contacts the workpiece at the desired location and angle, resulting in the removal of material in a controlled and precise manner. The next one is the grinding wheel. The grinding wheel is a fundamental and critical component in a grinding machine. It is the abrasive tool responsible for removing material from the workpiece during the grinding process. Grinding wheels are typically composed of abrasive grades, such as aluminum oxide, silicon carbide, or diamond, banded together with a matrix material such as resin, vitrified, or metal. Hand wheel for saddle. The hand wheel for saddle in a grinding machine is a manual control mechanism that allows the operator to move the grinding wheel saddle, the part of the machine that holds the workpiece, and moves it back and forth during the grinding process in a precise and controlled manner. By turning the hand wheel, the operator can adjust the position of the saddle along the machine's horizontal axis, enabling them to set the desired depth and position for the grinding operation. This manual adjustment is crucial for achieving accuracy and the precision in grinding process, as it allows the operator to finely control the depth of cut and the position of the workpiece relative to the grinding wheel, resulting in the desired surface finish and dimensional accuracy. The next one is the base. The base is the bottom part of the grinding machine. What 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 is supporting the whole grinding machine. So the next one is the hand wheel for the work table. The hand wheel for the work table in a grinding machine is manually operated, controlled mechanism that allows the operator to make precise adjustments to the position and movement of the work table. By turning the hand wheel, the operator can move the work table horizontally or vertically, adjusting its position relative to the grinding wheel or the workpiece. This fine control is essential for setting the depth of cut, the angle of the grind, and ensuring the grinding operation achieves the desired precision and accuracy. The hand wheel provides a tactile and intuitive means of making these adjustments, giving the operator the ability to fine-tune and the grinding process according to specific requirements of the workpiece and type of grinding operation being performed. And for the last one is the hand wheel for head. The hand wheel for head in a grinding machine is a manual control mechanism used to adjust the position or orientation of the grinding head or grinding wheel with precision. It allows the operator to make the fine adjustments to the vertical or horizontal position of the grinding wheel, ensuring that it is aligned correctly with the workpiece. This is crucial for achieving the desired depth of cut and maintaining the necessary tolerances during the grinding process. By June, by turning the hand wheel, the operator can raise or lower the grinding head or tilt it to the desired angle, thereby controlling the material removal and quality of the finished surface. It offers means of fine-tuning and grinding operation and plays a significant role in achieving the desired results in grinding process or grinding applications. So for the next one, grinding machine operations. So before we go to the sum of exa- so before we go to the grinding op- so before we go to the grinding machine operations, let's watch a video.
External cylindrical grinding, grinding wheel, workpiece. External cylindrical grinding produces a straight or tapered surface on the workpiece as shown. In this grinding, the workpiece is rotated about its axis between centers and feed horizontally. Surface grinding. Surface grinding produces flat surface. In surface grinding, the workpiece is ground by either periphery or by the end face of the grinding wheel. In surface grinding, the workpiece reciprocated at a constant speed below the rotating grinding wheel. Form grinding. In form grinding, the grinding wheel is formed to the shape of the ground surface. Gear grinding is the best example for form grinding. In this, the grinding wheel is shaped to the shape of the gear teeth. Centerless grinding. In centerless grinding, the workpiece is supported between grinding wheel and regulating wheel on the work rest table. Centerless grinding is used for finishing long slender bars.
So the next. So we're going to the other types of grinding. Surface grinding. Surface grinding is a precision machining process used to produce a smooth, flat, or contoured surface on a workpiece using a rotating abrasive wheel. It is commonly employed to improve the surface finish and dimensional accuracy of a wide range of materials and components. Cylindrical grinding. Cylindrical grinding involves the use of cylindrical grinding wheel to create a precise, cylindrical shape or profile on a workpiece. This process is frequently used for machining shafts, rods, and other cylindrical components with tight tolerance requirements. Internal grinding. Internal grinding is employed to produce accurate internal bores and holes with a fine surface finish. A small, high-speed grinding wheel is used to access and grind the inner surfaces of workpieces, often used in applications where external grinding is not practical. The centerless grinding. In centerless grinding, a workpiece is supported between two wheels, a grinding wheel and a regulating wheel, with no need to speed for a spindle or centers. It is a high-precision method for grinding cylindrical parts, offering advantages such as fast material removal and minimal setup time. Thread grinding. It is a special process that used to create precision threads on workpieces. It is crucial in industries requiring high thread quality and accuracy, such as aerospace and automotive manufacturing. Gear grinding. Gear grinding is a precision machining method for producing high quality gears with close tolerances and specific profiles. It is essential for the applications where smooth gear operation is critical, like in transmissions. The jig grinding. It is a highly accurate machining technique that uses a tool called a jig to guide the grinding wheel and produce intricate shapes, holes, or contours with exceptional precision. Tool and cutter, Tool and cutter grinding. It is the process of sharpening or manufacturing cutting tools like drills and mills and reamers, ensuring they maintain their cutting effectiveness and accuracy. The next one is the clip feed grinding. Clip feed grinding is a slow, deep grinding process ideal for removing large volumes of material from workpieces, commonly used for roughing and semi-finishing operations. And for the last one is the Blancard grinding. Blancard grinding is a surface grinding method that uses a vertical rotary table and a large grinding wheel. It is suitable for grinding large, flat work pieces to achieve a consistent and parallel surface finish, often used in the production of industrial parts like base plates and steel sheets.
Setup and safety precautions in grinding machine operations. Workers can prevent any potential mishaps and injuries when using grinding machines by adhering to these safety guidelines. 1. Check the speed of the grinder. The speed of the grinder must always be monitored. Grinder should not rotate faster than the maximum RPM stated on the wheel. 2. Check grinding wheel and grinding guard. Never use a grinder without the grinding wheel guard, which is provided for protection. Check the grinding wheel for any kind of crack or damage before using the grinder. 3. Ensure proper assembly of flanges and other parts. Grinding wheel consists of several smaller parts, which should be properly assembled and tightened together. Make sure that the right flanges are used and attached properly for a smooth movement. Ensure that there are no traces of burr or flush. 4. Use right wheel dimension. Using the right dimension of the grinding wheel plays an important role in ensuring safety and achieving higher efficiency. Using the right dimension wheel also helps in achieving the maximum allowed rotation speed of the grinding wheel. 5. Always test before running. Grinding must always be tested before beginning any kind of work. Test run the grinder in a safe enclosed area such as beneath the workbench to detect any kind of damage or fault in the wheel or the grinder. 6. Always wear personal protective equipment. Never use the grinder without wearing all the personal protective equipments and clothing such as goggles, helmets, mask, ear protection, gloves, leather aprons, and etc. Also ensure that the personal protective equipment and tools are in proper condition before using any of them. 7. Carry out maintenance at regular intervals of time. Carry out maintenance of grinders at regular intervals of time and as stated by the manufacturer. Never use a faulty device and carry out all possible preventive maintenance for safe operation of the grinder. This concludes the grinder machine section of our discussion. We will now move on to the lathe machines. Lathe machines and lathe operations. Now, what is a lathe machine? A lathe is a machining instrument used mostly for shaping metal or wood. It operates by rotating the workpiece around the stationary cutting tool. The primary application is to eliminate undesired sections of the material, leaving behind a perfectly formed object. The purpose of a lathe is to remove material from workpieces by exposing them to a cutting tool. The workpiece is clamped to the lathe and spins while pushing onto a cutting tool. The circular movement of the workpiece enables for the removal of material to be done quickly, efficiently, and precisely. The next will be the main parts of lathe machines.
Main parts of lathe machines. First, chuck. It enables the installation of challenging non-round, square, or triangular workpieces. Chip pan. It's on the lathe's bottom. The chip pan collects the chips produced by the lathe process. Headstock. The headstock is typically positioned on the left side of the lathe and outfitted with gears, spindles, chuck, gear speed, control levers, and feed controls. Spindles. The hole in the headstock through which bar stock can be fed. allowing shafts up to twice the length between lathe centers to be worked on one end at a time. Hand wheel. A hand wheel is used to move a cross slide, carriage, tailstock, and other components. Legs. They are supports that support the full weight of the machine. The most common procedure is to utilize cast legs. To avoid vibration in the machine, both feet are firmly connected to the floor via foundation locations. Tailstock. The workpiece is normally on the right side of the lathe and it's supported at the end by the tailstock. Feed rope. It moves the carriage from left to right and vice versa. Cross slide. Mounted on the carriage traverse, slide, and feeds tools into the workpiece via a hand wheel. Carriage. The carriage incorporates an apron, saddle, composite support, cross slide, and tools holder and is situated between the headstock and tailstocks. Bed. The primary components of the lathe are attached to the bed. It consists of the headstock, tailstock, carriage rails, and other components. Apron. It is attached to the carriage front and contains the mechanism and controls for moving the carriage and cross slides. Types of lathe machines. First, speed lathe machine. The adjustable slide holds the bed, headstock, tailstock, and tools post. The tool is positioned on an adjustable slide and it's only fed into the work by hand. This feature of lathe machines has a speed range of 1,200 to 3,600 revolutions per minute. The headstock, with only 2 or 3 spindle speeds possible. The depth of cut on a speed lathe machine is limited. Engine lathe machine. The gear mechanism or pulley system powers these devices. The term engine lathe refers to early lathes that were powered by steam engines. All of the components on an engine lathe machine are comparable to those on a speed lathe. For instance, a bed, a headstock, a tailstock, and etc. Bench lathe machine. These lathe machines are used for extremely fine precision work. The bench is equipped with bench lathe machines. It includes all the components that the engine lathe and speed lathe share. Nearly all of the tasks that the engine lathe and speed lathe do are handled by the bench lathe machine. Tool room lathe machines. The tool room lathe machine is identical to the engine lathe but offers a variety of speed. Up to 2,500 revolutions per minute, the spindle speed ranges from a very low to a moderate pace. A chuck, a taper turning attachment, a draw-in collect attachment, a stable and follower rest, a coolant pump, etc. are included in addition to the other object. Capstan and turret lathe machine. These lathe machines are employed in manufacturing. Instead of tailstock, these vehicles are equipped with hexagonal turret heads. Additionally, it has 3 tool posts. Multiple tools may be installed and fed into the job in the correct order in this kind of lathe machines. The primary benefits is the rapid production of various activities and components. Special purpose lathe machines. As the name indicates, these lathe machines are employed for specialized tasks as well as industrial operation. Special operation such as drilling, grinding, reaming, boring, and so on are done on this lathe. Automatic lathe machine. These lathes are heavy-duty, high-speed manufacturing lathes. Here, the tool and feed changes are automated. A single operator may manage 5 to 6 automated lathes simultaneously. The function of lathe machine include turning, facing, taper, turning, knurling, grooving, splitting up, electric turning, thread cutting, and reaming, among others. CNC lathe machine. In a CNC, computer numerical control lathe, the workpiece is rotated around the main spindle while being cut with a cutting tool in the required form and size. A simple CNC lathe uses two axes and an 8 to 24 station turret to operate the cutting tool in a fixed position. The use of a CNC lathe assures constant product quality and does not call for highly qualified workers.
Okay. Lathe machine operations. Ayan. Okay, meron tayong video dito about lathe machines operations. Panoorin muna natin.
Facing operation. In this video, we will discuss the facing operation in the lathe. Facing is an operation which produces flat surfaces. Facing tool, workpiece, chuck. In this operation, the tool is fed at right angles to the axis of the workpiece. It reduces the length of the workpiece. Various types of lathe operation we'll discuss in the next videos. Turning operation. In this video, we will discuss the turning operation of the lathe. Turning is the machining operation in which excess material is removed by rotating the workpiece against a cutting tool. Workpiece, tool, feed, that is F, depth of cut. Knurling operation. In this video, we will discuss about knurling operation in the lathe. It is the process of indentation of various forms on cylindrical surfaces. Knurling tool, workpiece. A knurled tool is held in tool post and pressed against the rotating work. It is done to provide grip on holders and screw heads. Grooving. In this video, we are going to see about grooving operation. Grooving is also known as recessing, undercutting, or necking. Consider a workpiece held in lathe. The grooving tool is fed crosswise against the rotating workpiece. A groove is the location of an indentation in the part. This indentation can be square, round, or angular in the shape. The function of a groove is usually to allow room for a fitting part such as a rubber O-ring. It could also be the place where another part fits into this part. Grooves also provide a relief in the backside of a thread where the thread terminates. Drilling. In this video, we will discuss the drilling operation of the lathe. It is the process of making holes on workpiece. The drill is fed slowly into the workpiece, which is revolving in a chuck. Chuck. Workpiece. drill tool. The drill is held stationary in the tailstock spindle. Reaming. In this video, we are going to see about reaming. Reaming is the operation of finishing and sizing a hole which has been previously drilled or bored. Consider a workpiece held in lathe. The tool used is called reamer, which has multiple cutting edges. The reamer is held on the tailstock spindle either direct or through a drill chuck and is held stationary while the workers revolve at a very slow speed. The speed varies from 0.5 to 2 mm per revolution. Hence, reaming is done. Boring operation. In this video, we will discuss the boring operation on the lathe. Boring is the operation of enlarging the previously drilled hole with the aid of single point cutting tool called boring tool. Workpiece, boring tool. If the hole is enlarged only through a certain length, then it is referred as counter boring. If the tool is feed at an angle to the axis of rotation, it is called internal taper turning. Enlarged hole, parting off. In this video, we will discuss the parting off operation on the lathe. Workpiece, cutting off tool, parting off is the operation of separating the finished workpiece from a bar stock. The operation involves feeding the cutting tool into the rotating workpiece.
Okay, ayun ang mga operations na meron sa ating lathe. Gaya ng una, turning. Cutting tool removes material from the outside diameter of a spinning workpiece during the turning process. Its goal to reduce the diameter of the workpiece to the required dimension. Yan, una ang taper turning and contour turning. Excuse me. Sunod naman ay ang pacing. The workpieces are somewhat longer than the completed product during milling. Pacing is the machining of a workpiece perpendicular to the axis of rotation end. When pacing the tool advances along the workpiece radius, removing a small layer of material to achieve the appropriate component length and a smooth pace. Excuse me. Next one is parting. Parting is a machining procedure that results in the removal of component at the conclusion of machining cycle. Yan daw. It's parting off. Sunod ay ang grooving. Grooving is a turning technique that results in a thin incision or groove in the workpiece. The width of a cutting instrument determines the size of the cut. To manufacture broader grooves, many tool passes are necessary. External and facial grooving are the two types of grooving process. The next one is threading. Threading is a turning procedure that involves moving a tool along the side of a workpiece and cutting threads on the outside surface. A thread is a regular spiral groove with a fixed length and pitch deeper threads needs more tool passes. Okay, next one is knurling. The knurling technique produces serrated patterns on a part surface. Knurling improves gripping friction as well as the look of the machine object. This machining procedure employs a one-of-a-kind tool composed of one or more cylindrical wheels. Yan, makikita natin dito yung mga patterns. Yan, yan yung patterns para sa grip. Yan. Next one is boring. When boring, a tool is inserted actually into the workpiece and removes material along the inner surface to form a new shape or to expand an existing hole. Next is drilling. The materials removed from the inside of a workpiece during the drilling process. Drilling produces a hole with a diameter equal to the size of the drill used. Drills are usually mounted on a steel stack or a lathe tool holder. Next is reaming. Reaming is a calibrating technique that enlarges the workpiece hole. When reaming, the reamer penetrates the workpiece actually through the end and extends an existing hole to the diameter of the tool. Reaming removes only a small amount of material and is frequently used after drilling to obtain a more precise diameter as well as a better interior finish. And the last one is tapping. Tapping is a technique of inserting a thread cutting tool actually into a workpiece and cutting the thread into an existing hole. The total corresponds up to a bit size that can be accommodated by the specified thread cutting instrument. Yan. Yan daw yung tapping. Now, mag-move on na tayo sa safety precautions in late machine operations. Yan. Ito daw, these are the safety precautions in late machine operations. Meron tayong ensure cutting tool is sharp. Yan. Prior to using a lathe, inspect the cutting tool to ensure it's sharp. Cutting tools deteriorate over time. The more you use the same cutting tool, the duller it will become. Ayan, pupurol daw ang ating tool. Wear impact resistant safety glasses. According to the Bureau of Labor Statistics or BLS, roughly 20,000 US workers per day sustain an eye injury dahil hindi sa pagsusuot ng resistant safety glasses. Yan, dapat natin itong maiwasan para hindi tayo magkaroon ng eye injuries. Next one is secure workpiece to lathe. Yan. You should secure the workpiece to the lathe before cutting or otherwise manipulating it. Most lathes have clamps that you can use to secure and hold the workpiece. After placing the workpiece on the lathe, you can clamp it down. Once clamped, the workpiece will remain steady while you cut, sand, turn, or knurl it. Number 4, clean and remove scrap material. Whether you are using a lathe on a wood or metal workpiece, it will likely create scrap material as a byproduct, also known as chips. Scrap material can pose a risk of injury if you fail to clean it. While the lathe is torn off, use either a vacuum or brush to remove scrap material. By cleaning and removing scrap materials, injuries are less likely to occur when operating a lathe. The last one is maintain clean obstruction-free floors. You should maintain clean floors around that are free to obstructions and tripping hazards. Because lathes offer an elevated working surface, you probably won't look down at the floor much while operating one. As a result, power cords, tools, boxes, and other obstructions may cause you to trip and fall. So, that's it. Thank you for taking your time listening to us today. The drilling machine, grinding machine, and lathe machine are pivotal tools in the advancement of numerous industries. We hope this report has provided you with the insight and knowledge about these tools and their significance in different workshop operations. So, that's all for today. Thank you very much for listening.